So go to y equal to, right? When you press y equal to, you should land on this screen. Make sure you look onto each other's graphing calculator if you don't have it. You need to follow along. So like Gregory, you don't have one, you need to go see somebody. Margos, you need to go see somebody's graphing calculator. You might want to see someone's graphing calculator. I just don't grab one from that too. Yeah, go grab it. Go grab it. Hurry up. Hurry up. You should have done that earlier. Why? I already mentioned graphing calculator. Waiting for the last minute to do that. Wasting my time. Okay, so go ahead and type in square root of x. Now, there is a square root functionality when you press second and x squared button, you're going to get a square root. And then you can press x. This is a button where it has x, different variables. You press that, it's going to give you x. So here you go, right? Square root of x. I'll show you another way to do this where it's equivalent, right? So square root of x is x to the 1/2 power, right? So it is possible that you can also do this, x to the power, parenthesis, 1 divided by 2, parenthesis. If you put in this versus square root of x, you're going to get the same results. Look up to somebody else, or you have
Greg is
getting All right. So I'm going to go back. And just do the traditional format of square root of x. Okay, like this. Now, I want to go to a table. I want the calculator to show me the table values, but I need to kind of set some parameters because your calculator doesn't know what values I want to start with. All right, so I want to set up my table. If you look at right above this button, Windows, it has a lettering table set. Right, TBLSET. That is short for table set. So I want to press second. I want to press window. It will show me the table set. This is the setting up of a table. Setting up a table. Now, when I set up a table, typically, right, handwritten table, we typically start with some easy numbers, 0, 1, 2, and then we'll go to the negative. Why don't we just go ahead and start with the negative? In fact, maybe I'll start with -5. So I'll go to -5, and then the delta table, that means every increment. How much do you want every increment? I want every one unit. So if I start with -5, the next number is going to be -4, right, -3, and so on and so forth. So that's how I will set up my table. Now I need to go to the table. So then I go to the table. Notice above the graph button that's table. So the lettering above any button is second. So second graph, that should give you a table. Look at this, right? My XY table. X goes from -5 all the way to +5, and then the value, Y value, corresponds to it. Now, from here, this point on, that makes sense, right? 0, 0, 1, 1. Square root of 0 is 0. Square root of 1 is 1. Square root of 2, right? Square root of 2 is 1.4142. Square root of 3, square root of 4 is 2. Makes a whole lot of sense. Tell me, what happened? Why are these errors over here? Why do we have errors right here? Yeah.
Because you can't square root a negative.
You cannot square root -5. You cannot square root -1. That's right. So they are now their real their values, their mathematical values, what we call the imaginary numbers, but they're not real numbers. And graphs, you can only graph real numbers. So over here. Now, if you just look at these numbers, you have a sense of what a graph would look like without actually graphing it. Just look at the number. Now, I want you to start practicing looking at numbers like this and see if in your head can map out some sort of graph. It's easy for some people, not so easy for others. Not so easy for me. It requires some training. But some people are really good at numbers. There are students that I've taught, they can like look at a data set and then their brain is like making sense of it. Crazy stuff. But for me, I had to actually graph it out. Anybody can figure out what a graph looks like? Can you see it? Right, so yeah, so 0, 0, so you see 0, 0, over here, 1, 1, like this. But then over here, 2, then it's just a tad over, and then 3 over, and 4 just becomes 2. So it's gonna be like this, right? So go ahead and graph it. What do I graph? I just press graph, and then it shows up. Okay? So this is the graph.
Right.
Right. Right. So from this point on, you can use your calculator as long as you know how to operate, right? Getting the values that you need from the table, getting the graph. Now, by the way, over here, this graph, I have from -5 to 5, -5 to 5, and obviously, as you can see, this vertical screen, right, the vertical dimension is a little shorter, but it still try to fit 5 units. So you can see that this is not exactly like your graph paper. It's a little compressed, right? A little compressed. You can actually change the range and the domain of the window by going to window. This button, window right here. This button. When you press that button, you are telling what the screen, your calculator screen, what to display. What this is set up is what we're displaying from -5 to +5 for the x, and then -5 to +5 for y, and every little marking is 1 unit. Every little marking, right? Now one could say I want this to be -10, right? You can do this -10 to +10. And then over here, exactly the same way. Say I want -10 to +10. And then you graph this. Right, it just give you a little bit more. Okay. I want to go back a little bit. I want to go back to window to go back to -5, just simply because -5 to 5 gives me a better vision of the shape of the graph. Okay, so this is what I have. So that's number 1, easy stuff, right? Piece of cake. Now, next one. Let's go back to y equal 2, and I'm going to go to y2. This time, I'm going to graph my second one. The second one is square root of 3x. So go ahead and input square root of 3x. So square root of 3x, I go second, right? X squared, and then 3x. All right? So now I'm going to go ahead and look at the table. I'm going to look at the table for now. So second graph, and go back to the table. Now notice this table shows me the y1 value and then y2 value, because I have 2 functions in the y equal to. So the xy table for the second one literally is this x right here and then y2, right? Makes sense. Now, if you look at it, it is square root of, so now second problem right here. Second problem right here is f of x equals square root of 3x. It makes sense to me, right, that -1, starting with -1, that's going to make it square root of -3. It's going to make it undefined, or make it imaginary number. So everything below -1 is going to give you error, right, imaginary number. If you put 0, you end up with 3 times 0, which is 0, square root of 0 is 0. So that makes sense. This one, when you put 1 in there, it becomes 3, and becomes, instead of square root of 1, you got square root of 3. Over here, instead of 2, you end up with, right, you put 2 in there, 2 times 3 is equal to 6, so you end up with square root of 6, and so on and so forth. Before pressing the graph, what do you think this red graph is going to look like in comparison to the blue graph? By just looking at the number. Yeah.
It's gonna be more.
More, how so? What is the shape of the graph, what does it look like?
It'll probably be a similar shape, but just above it.
Similar shape, but just slightly over it, right? Similar shape over it, and the positionality is exactly the same. You're gonna be hanging out in the same position, except just a little bit stretched out, right? So let's graph it. Good job. You have accurately predicted by looking at the data. All right, number 3. Number 3, center page, we got square root of x plus 2. All right, so go back to y equal 2 and go to y3. We got square root of x plus 2. Right, x plus 2. Square root of x plus 2. Now, again, don't graph right away. Don't graph it right away. Go to the table. Let's take a look at the table. Let's take a look at the table. What do you notice about these values? What can you tell me about these values? Yeah, and you need to borrow somebody's screen to be able to follow along. Because the next time when this comes along, you won't be able to do this. All right, what can you tell me about y3? What observation can you make by looking at this? Huh?
It's the same as y1, just all the values are 2 places higher.
Oh, these values are exactly the same as the y1, except it got shifted by 2, right? By 2 to the negative side, though, huh? Right? It got shifted to the negative 2 instead of starting at 0. What is it about the function in of itself, the writing of the algebra, that had made the shift? What is the writing on the algebra has made the shift to the negative side by 2 units?
The x plus 2.
Yeah, this thing right here somehow shifted to the left, right, or negative by 2 units, right? So on the graph, if you look at the graph, it makes sense, right? It's the same blue graph, except everything gets shifted 2 units over to the left, to the negative direction, right? Because why? Because why? The starting point for the f of x is 0, but if you put 0 in here, you're already going to be at 2. So your starting point has to be negative 2 in order to make that whole thing equal to 0 as the equivalent of 0 over here, right? Right? In order to make square root of x plus 2 equal to 0, your x has to be negative 2 in order to make that entire square root 0. That's why it makes sense it has shifted to the left. Questions so far before we keep moving on? Okay, next one, number 4. F of x is equal to square root of x plus 3. Right? So in this case, the 3 is outside the square root. So go ahead and plug it into this lineup of equations. Lineup of equations, so we got square root of x, and then the plus 3 like that, right? Okay. Now, again, I want to look at the table. So this time we're in Y4, the pink graph. The pink graph. If you look at the pink graph, how does the pink compare to the blue? How does the pink compare to the blue? Yeah.
It's just y1 plus 3.
Everything gets added by 3, right? The value, final value, when x is equal to 0, final value is 0 for y1, but the final value is 3 for y4. Final value is 1 for y1. The final value is 4 because 4 is 1 plus 3. So, and then final value for x equal to 2 for y1 is 1.4142. Over here, 4.4142. So just add another 3. This one, 1.7321. This is 4.7321. So everything over here gets added by 3. So on this this expression here, what makes it happen is this thing, right? This plus 3 right here, and this plus 3 right there allow you to shift the graph up by 3, right? So let's take a look at the graph. When we graph it, makes sense. See the comparison between the pink and the blue is a vertical shift or vertical translation, however you want to call it. Shift or translation. All right, moving up by 3. So good? All right, so here, number 5. Here, number 5, we got square root f of x is equal to square root 3x plus 2 and then plus 3. What do you think happens? How can we predict? Yeah.
It will go to the negative 2 times, and then it will go up 3.
So this 2 will move the graph to the negative 2.
And it will be up 3.
And then this 3 will move it up 3. But what about this 3 right here? Didn't we do something similar? Instead of the comparing to the blue, we're comparing to the
red.
The red. So it will be the red graph shifting 2 this way and moving up 3 up that way. All right? Take a look. Let me apply this. So 3x plus 2 plus 3. Let me look at the table real quick. Actually, no. Let me take that back. You can shift 2. Why not? The reason why you cannot shift simply just by 2 is because now we have a 3 right here. We have a 3 right here. And you had to look at this whole thing that will make it equal to 0. Right? 3x plus 2 equal to 0. 3x is equal to negative 2, and x is equal to negative 2/3. Right? So anything, if x is less than negative 2/3, it will make this square root a negative value. So this actually gets shifted to negative 2/3. So if you look at that, if you look at the actual graph, it actually didn't shift by 2. It shifted only to negative 2/3. Notice, 2/3. Does that make sense? And that has to do with this 3 right here. Now today, hold on, just give me a sec. If today you have a different equation, that look like this, square root of x plus 2 plus 3, then Archer's earlier assertion will make sense because this is just one singular x, right? A singular x, and this will shift by negative 2. But because there's a 3 right here, that means you have to look at this whole thing. What x value do you put in here that will make this whole thing 0? Oh, it's negative 2/3. Well, so what that means is that if this x is smaller than negative 2/3, then this whole thing is going to become negative. And then you're going to get an imaginary number. Make sense? That makes sense, right? Question on this? This is a little bit of a nuance look at it. Again, I contrast this with this. This would have been very easy. This would have been, okay, so this is just singular x. This shifted by negative 2, 1, 2. This one goes up, 1, 2, 3. And it will be right here. And that will be this graph. It will be a very easy graph. This one, on the other hand, this turns out to be the critical value, right? So that one is going to be, okay, negative 2/3 right here. So negative 2/3. And then the 3 is still 3, 1, 2, 3. So we'll move over here, right here, and then like this. Okay? So that is the difference. Question? Next one. I'll go to number 6. This one we have 1/2 square root of x. Now 1/2 is just 0.5, so 0.5 times square root of x. Now, what do you think the graph is gonna look like when you have 1/2 and square root of x? Yeah.
It's gonna be half of y1.
Everything gets reduced by value gets. So if instead of a regular square root of x graph, it gets compressed by half, right? Get compressed because all the y values gets reduced by half. So let's take a look at if that's true by looking at. I think what I'm gonna do is I'm gonna move my cursor to the equal sign and then press enter to unselect it. I'm unselecting it so it doesn't show. I'm keeping the equations on the screen, but when I do the table or graph, it won't show. So for example, if I do the graph, it shows 2, right? Shows the first equation, and then the orange will be the most recent equation, 1/2 square root of x. So you see, this literally cuts in the middle. Do you see how this blue line goes like this, covers this much area? This orange line cuts straight into the middle with the same curvature. So the top portion and the bottom portion, every x value you can see is half, right? And all because of what? All because of number 6. All because of f of x equal to 1/2 square root of x. Now we know that if you got f of x is equal to 1/3 square root of x, then your curvature, right? Your curvature is gonna basically cut through the 1/3 section of that whole thing. Does that make sense to you? Does that make sense to you? Okay, so what conclusion can I make of this? So I'm gonna substring real quick and then show you right here what conclusion can we make around these. Given all this, given all that, a conclusion, please. Our conclusion is that for a radical function, f of x, a square root of x minus h plus k, this a, right, a will basically give us the vertical stretch or compression. We just did that 1/2, 1/3, and so on and so forth. H, right? H, this will be the horizontal shift, and then K will be the vertical translation. Up and down. Put the graph up and down. Now, this can actually apply not only for the square root function, but it can be for any nth root function. And not all nth root function will shape the same way. So in a moment, we're going to look at what cube root of x will look like, what fourth root of x will look like, fifth root of x will look like. Okay, so, but this is very important, at least this one. Now, how is this? Do you notice that this is somewhat familiar? What other places have we learned up to this point that this kind of vertical shift, or vertical translation, horizontal shift, in compression and stretch has shown up in the past?
Oh, yeah.
Huh?
Literally everything that involves a function.
Every function, yeah. Remember parabola, the vertex form? Do you remember vertex form also has h and k? And the h and k will move back and forth, up and down. Looking similar to this. How about v, right? The v shape, the absolute value graph, right? You notice it's similar to this is the radical function. But remember last time when we do the reciprocal function, right, we have f of x equal to 1 over x minus h plus k. Remember that? Right? What's underneath here goes this way, this one up and down. Remember the quadratic? We have f of x equal to x minus h squared plus k with the a in front. Remember that? Exactly the same thing. H and k, these things gets moved around. You remember the absolute value one? Absolute value function f of x, right? They all move the same way. So all you need to do is understand the base function. So the base function for the quadratic, this is what we would call the base function. Right? It's what you start, right? And then this one, the base function is 1 over x. The base function of quadratic is x squared. Absolute value function f of x is right like that. And then all you need to do, you know what it looks like? This looks like this. And so that whole thing will shift around. This one, you know that this one looks like a parabola. And this one, you know that it looks like a V, right? It looks like a V, and then it will move around. And this one, it looked like this. So all you need is, remember I had said earlier, this class, Algebra 2 is just about bunch functions. And every function has a shape. And if you remember the base function, then all these complicated, additional things around it, these are kind of embellishment around it, the decoration around these functions, all it does is just move the functions around on the graph. Whether it stretches, pulling up and down, and moving around, that's what all these things do to the base function. So you just need to be able to identify the base function. Now, let's go to the next base function. The next one that I want to go over, let me unselect these. I just go put the cursor to the equal sign and then press enter, then I basically unselect it. I still keep it in the lined up. This time, what I want to do here is the cube root function. F of x is equal to cube root of x. So cube root of x, there is no cube root on the button, but cube root, you know that this just means x to the 1/3 power. So type in x to the 1/3 power, so x, and then this button is the power button, right? This button right here, this little arrow. When you press that, it gives you the superscript. And the superscript 1/3, you put a parenthesis, and then 1 divided by 3 parenthesis again, then you end up with this. X to the 1/3 power is cube root, right? Cube root. So if that's the case, then let's take a look at the table. So our table look like this. Surprisingly, we got values for the negative. Why? Yeah.
Because of action.
Because of the what?
Action.
No. Well, you cannot have square root of what?
Is it because there's no square root?
It's not a square root. It's a cube root. But cube root doesn't. Yeah, cube root doesn't. You don't have to have negative.
Odd number roots can have negative, but.
Yeah. Odd number can have negative. Because if you have even number multiplying even number of itself, you will never be able to have negative. You will always have positive. So in this case, you can have negative. So cube root definitely have negative value, right? Now look at this. This is actually, here is negative 1.26. Over here is 1.2599. They're actually the same way. I think this is just a round up because of spacing. Take a look at this. If you arrow it over and then go down to this part, this actually gives you the whole the large number of decimals that the calculator can provide. So this just means that this strings of decimals is going to go forever, and this number is exactly the same as this number. So exactly the same. So take a look at this, right? The negative values in this case are basically corresponding to the positive value in terms of the absolute value, and then it has some sort of shape. What do you think this will look like before we press the graph? Like this, and then over here, like that, right? Right, yeah. So go ahead and grab it. And guess what? This is your base function. This is your base function for the cube root. So if today I ask you to sketch f of x, so cube root look like this, right? Look like this, look like this. But today, if I say, oh, can you sketch out cube root of x plus 2 plus 3? What do you think will look like? Yeah.
Well, in the equation form, it's just you put it as x and then parentheses with a 1/3 with parentheses and then.
Well, it may be true, but all I'm asking is how would you sketch the graph? If I would sketch a graph like this, how would you do it? You know this. Yeah, Chris. Yeah, so it basically is this graph, but follows through the translation and the shift, right? So the shift is -2 right here, -2 right here. It translates to up 3. So your starting point is right here. Now your base graph is going like this and this, so it will go like this and this. Right? So I'll give it a try and see if that's the case. I'll go to my phi. So this is, I have to be careful, right? Type in this equation, but it will look different. It will be like this way, x plus 2 parentheses to the power of 1/3, and then the whole thing plus 3. Okay, plus 3. And then if I graph this, look at that. Our prediction was correct, right? It is using the same base graph of the cube root, but shifted 2 spaces to the left and 3 up, and then keeping the entirely the same shape. Okay. More. I'm gonna delete this. Delete all is in between one. I'm gonna keep the. Actually, let me delete that one and redo it again. So right now I have a square root of x. How about a 4th root of x? Because we did a cube root, but did a square root, we did the cube root. How about let's do a 4th root? So 4th root will be x to the power of 1/4. 1/4. What do you think this graph is going to look like?
The same basic shape as it's just the square root of x, but it's magnified.
So same shape, but
Like there is difference.
a little bit different, yeah.
Are they gonna be smaller?
It's gonna be small, meaning like more compressed.
How do you guys see that? Is there a flashback on Peter Griffin? See the light in
There you go. Oh, I forgot to highlight this. I'll highlight this. So make sure these 2 cursors are highlighting the good. Yeah. Right. So our blue was square root of x. The red one is the 4th root of x. It comes out a little bit higher and then gets compressed because everything gets 4th rooted. Right. And so, and then 4th root also does not have negative value because the 4th root is an even number root, right? An even number root, you can't have a negative value, right? Now, so one could conclude that if root of x fifth root of x is gonna look like which one?
3, okay, the cube.
Cube root. Fifth root of x is gonna look like cube root because it will have positive and negative, but it's gonna be more compressed. Just really quick, we can do this real quick. We'll do the cube root first. We'll do the cube root 1/3, and then we'll do a fifth root 1/5, and let's graph it. Right? Do you see it? See it? Makes sense. So they stack together, but then they get compressed a little bit. Questions on this? That's basically what I have for you today for section 5.3. We still have about 15 minutes. The last section that I talked to, they had some question about the homework that Mr. Chen assigned to you on the worksheet. Do you have any questions on that I can go over with you in class?
Wait, which one? 5-2 or 5-1?
5-2. Have any question on 5-2? No, then I need to show you one more problem, then we'll be okay. We'll be done. Okay? And we'll do a little bit more next time. So, I4, we want to solve radical equation. Just start with one simple example. Square root of x plus 5 minus 1 is equal to 3. I kind of want to explain this a little bit further. If you kind of think about this without just, if I'm going to look at this, think about this. Think of this graphically. Square root of x plus 5 equal to 1, if we can think of this as f of x, we know already from today's lesson that this is super easy to identify, right? This is basically 1, 2, 3, 4, 5, -5, and then drop by 1, -1. And then your graph basically look like this. Let me redraw this a little bit. Like this. This is your f of x. Right, so you can think of this as f of x here. But you can think of this as g of x, right? Where it's g of x is equal to 3. So maybe 1, 2, 3. Maybe 3 right here. 3 right there. And then so the graph This is g of x equal to 3. So when you set this equal to each other, what are you looking for on the graph? When you have an equation and you think of one side of the equation as one function, another side of the equation as another function, you set it equal to each other, what do you think that is? Yeah, what does that mean?
That you were asking about what.
Not the actual value, but what is the concept? When we have an equation, what's the concept? What are we thinking in our head? Here. That's where the graphs cross. That's right. Intersect. Intersecting point is where the solution is. This is the solution. This point is the graphical understanding in our head. We should say, oh, that point is in fact what this means. So every time, like what makes me a math teacher versus someone just starting out studying math is that every time I see something like this, in my head, I'm seeing this. Does that make sense? I mean, I may not know exactly what number that is in terms of actual value, but in my head, conceptually, I'm seeing this not just bunch letters and numbers. I'm seeing this as someone is communicating that, hey, we had two things that are crossing each other. Does that make sense? And so that's how we solve problems. That's how we think about how to solve problems. Okay, so that's how we do it. And now the question is, how do we solve this problem? Solving this problem, very simple. We want to simplify and isolate the radical. We always want to isolate. We have a radical here and a number out here. Move the number to the other side. Right? So that's how we isolate the radical. So we make it x plus 5, and then make this 4. Right? Now, then we square on both sides, right? We square on both sides to get rid of the radical. Then we end up with x plus 5 is equal to 16. And then solve for x, right? So that's 11. Okay? So what that means is, I mean, this graph, obviously, I didn't, I was just sketching it. But in actuality, this will land on 11. That will land on x equal to 11. That will be my final answer. Now, it is possible that when you solve something like this and you end up with two answers or one answer, and then you look at the graph and you say, oh, there's no way. Because you can plug it back into the original graph, and then somehow it won't work. Why? The reason why is this. Whenever you square something, you have fundamentally changed the equation. So you always have to check and see if this number is going to work back into the original equation. So that's check. We have to always check. By taking this back in here, so we have square root of 11 plus 5 minus 1. Put a big old question mark above the equal sign and say, would that actually equal to 3? Well, yes, right? We end up with 16. Square root of 16 is 4. 4 minus 1 is 3. So 3 is indeed 3 equal to 3. So therefore, this answer is checked. So we can trust that answer. It's possible to experience some solutions just like the previous chapter. So you have to always check. Okay. All right, that's it for today. Have a good day, and I'm gonna pass out your test. Yeah, put it right here.
We'll wait until the last.
I don't know what the chat's talking about.
I lost mine. I'm not gonna put it.
I lost
I
it.
put it myself. It's not there anymore.
I'm like, I always ask
Isaac. Gregory. Every. Kaylin. Nia. Eva. You didn't do a makeup test?
No, I didn't get the chance to. I asked you about it, but he said to wait until you were here. It's either around like, it said either